Hey, good afternoon, good morning, good evening, wherever it is that you might be listening. This is a talk about ROA deployment in the DNS core. Where I'm coming from with this, my name's Ed Lewis, by the way. I work for ICANN. I've had a long experience working for registries. I've worked in all sorts of TLDs out there. I've worked on DNS protocol development and so on. I've seen this, I've seen a lot of things get built and rolled out in the past. Now, one of the interesting things about this process is to look at how operators adopt new technology. In the past, there was the assumption that technologies should just be adopted because they are good things. However, I've learned that a lot of times, if you look at how operators treat a new technology, it tells you a lot about whether the technology really is ready to go or what other improvements are needed for it. So, is it new technology ready for operations? It's not really yes or no, it's a sliding scale. And I'm going to look at one case of this. Now, the talk, I'm going to look at the adoption of route origin attestations, which are part of the routing public key infrastructure. These are used to protect routing, the routing system, which many people are probably really familiar with from other talks. But I'm looking at only the routes that are leading towards servers that are part of what we call the DNS core. And so from here, I'm going to talk about two things initially. What is a DNS core and what are ROAs? The first, because it's a small concept that I've been working with by myself. The latter, because I wanted to make sure that you see that I understand what I'm talking about, or maybe I've got the wrong thing. I just want to make sure about that. So first, the DNS core. It's this green area on the slide, which is the top of the DNS namespace. It starts with the root zone. It starts with the TLDs, the top level domains that we're familiar with that have the names of everything in the internet below them. There's also the address and routing parameters area that has the reverse maps for IPv4 under inadder and IPv6 under IP6. And there's some other structures that are inside of here that I collect together to create what I call the DNS core. Outside of that is everything else that really uses the internet out there. You're probably more familiar with what's outside the core than what's inside the core. Now, I want to take one side step here and say that in my talk, I'm going to talk about TLDs. And I'm using the word TLD in my talk sometimes, not exactly the correct way. TLDs, we generally think of the CCTLDs, the jurisdictional based or country code is what CC stands for, TLDs out there, the generic, the commercial TLDs out there. But I also throw in the reverse map as part of that because they kind of behave the same way when it comes to the DNS protocol itself. The protocol doesn't differentiate between forward map and reverse map. And I like to keep these all together. And having worked for an RIR, having worked for forward domain name registries in the past, it's the same technology. We really need the two to all work together. There's not really a divide, except that there is a divide in the mission that they cover. So the core, the upper reaches of the core, let me give you some caveats about that because this might play into how you evaluate what I'm saying here. The space up above tends to be pretty stable in the membership. TLDs do come and go, but not many a day. Every once in a while, they come and go. In the last couple of years, a few have been pulled out. Not a great amount, but some. The operators in this area too have the DNS as their primary mission. The reason why they exist or they're in business is because of the DNS. So they kind of have to really give it that's their top priority operational wise. And the protocol, the DNS protocol, surprisingly, is at its simplest in the core. It's not a very complicated area. Now, outside of the core, there are higher traffic zones, there are higher valued zones, there's greater functionality, and there are zones that are really well engineered. I mean, the core is not special in certain ways, but it's an area that's good for studying. Quickly, but the ROAs, because I want to get on to the rest of the talk. A ROA is a route origin, which is the IP prefix and the last hop ASN that I get information about. And the attestation signs that the combination of prefix and origin and the origin ASN are approved by whoever it is the IP prefix is allocated to. So the question, let's go back. The question is, what is ROA signing happening in the DNS core? How much of it is out there? It's a relatively new technology. It's how far have we gone along? If it's low deployment, it's been a hard sell. If it's high, it's probably solving an immediate need. Now, beyond just a simple number evaluation, I want to look at patterns of this to see where it is. If it's not full, what's going on? How is it being deployed out there? And I want to point out too that as part of any kind of a security of this kind, There's signing and validation, and I'm not talking about the validation end of this. I'm just talking about the signing. Are these statements available? My method is pretty simple. I create a census of the DNS core. I look at everything that's in there, the zones that are there. The zones use name servers. The name servers use addresses. Addresses have route originations related to them. I get the ladder mapping from Team Cymru's IP to ASN mapping service. That's my source for routing information. And whether or not there's a ROA or not a ROA, I get that from a list published by the RIPE NCC, which just has a list of everything that's been validated. And my percentages are yes divided by yes plus no. Pretty simple calculation. So after a lot of this work, putting the stuff together, I come up with this pie chart, which is current as of 24th of January. And it shows that just a bit more than 1 in 4 routes leading to the DNS core are covered by a ROA. And to give you some more orientation to what my calculations are coming from, I have some numbers on the right-hand side of the screen. The number of zones is 3,000 or so. That includes all the TLDs plus their substructures. There are about 1,774 TLDs, and again, that's counting the 1,500 or so forward map TLDs plus reverse map net zones in there, and so on a few others. There are only 4,300 name servers involved because there's a lot of sharing. For all those zones, all those TLDs, they only use 4,300 name servers. And there's only about 7,000 addresses, meaning that many name servers are sharing the same address. And below that, route origins, there are much fewer, only about 2,000 total. There's a lot of sharing of, or commingling of services as you go down the stack, so to speak here. Now, I have about 5 months of data in this particular measurement system I built. And I was able to go back to see that on the left-hand side, you see a chart which shows a pretty steady growth from August of 2020 to now. On the right-hand side, there's another chart which is actually the same chart. The difference is the scale. And one is showing that from 22 to 25%, it's going up. But from 0 to 100, it's kind of flat. And so it's going up, but it's taking some time to get there. And we're going to see at this rate, if I just took that line out, it'd be 9 or 10 more years till we get to full deployment. Now, one number is not enough here. I want to look at some of the categories that are out there. IPv4 versus IPv6 is one of the categories that we usually look at for routing information. And then we'll look into the DNS core. We have the CCTLDs, the GTLDs, and reverse map as individuals. And maybe there's some other way to divide this up. What I'm looking for here is what are the decision points in the architecture where you might want to address what needs to be done to the protocol. So v4 versus v6, they're pretty similar. It used to be that IPv4 or v6 would be different because of the experience we had with these two protocols. And largely, it's not much of a difference anymore. It's just like a 3% difference between the two, between 24.5% and 27.5% rather. But in doing this chart, I was wondering why the numbers were just off a little bit, because I look at my counts and they're different. And being that when I'm writing my software and I'm not that good at it, sometimes I make mistakes. But in this case here, what stands out is the number of TLDs. There are 1,774 TLDs counted for v4, but just 19 less for v6. And I went back and I trolled through some data out there, and I found out that's true, that there are about 19 of the 19 TLDs out there that still don't have IPv6 servers out there, which is surprising to me, but not part of what I was studying here. But I just thought that was interesting. So if I look at now the zones by where we categorize them at some level, GTLDs have a very small sliver of ROA deployed out there. Very small number of routes are covered, 13%. CCTLDs, about 1/3 are, and the reverse map, they're 2/3. And the reverse map, we're talking about the places run by the RIRs who have been promoting the ROA technology quite a bit. So it's not surprising to see kind of a much higher adoption with reverse map than in other places. So looking at this, I mean, there's a couple of things that were surprising to me, because I do know a lot about how the TLDs all work together. There are a lot of CCTLDs and GTLDs that are run off the same platform, so they should be together. And now we expect the numbers to be closer. But still, there's quite a bit of difference out there. In the reverse map, there is actually one organization that does GTLDs, CCTLDs, and reverse map all together, but only one. But we have all these different configurations. We have different agreements out there, trying to find out where things are decided regarding the deployment of routing technology and who needs to be pleased to roll this out, or where the concerns that come from are kind of all over the place. So taking a look at what I have understood to be the way things are put together, we have this stack. Up on top, registries have a policy, who's allowed to list their names in my dot whatever TLD out there. And that's a registry administration takes care of that stuff. And there's the front end to a database. The registry database is something run by an organization, and it produces whatever mapping, whatever they want to do with the registry out there. They have we call the whois data comes out of that. The RDAP data comes out of that. But we have the DNS is one of the products. The DNS and DNSSEC comes out of that. Then we come down to DNS server hosting. Now that kind of stuff generally is done by a DNS operator. The largest one out there the largest one in terms of number of TLDs is around 250, and I call those DNS houses. There are a couple clumps of these out there, and I don't have details much in the slides to keep this in time for the talk. Now below that, there's server hosting. That's another layer. People who run servers for other people, and there are up to 600 TLDs in one of these what I call AS houses. An AS house might be the wrong name, but it's basically a collection of the Atom System origins that seem to share that have DNS servers in them. Now it's kind of surprising that the largest one of these is much bigger than the largest DNS operator out there, because there's some commingling, some sharing of these services. In some cases, you actually do have organizations that run all three of these layers. In other cases, you have organizations that only run the top layer, and they contract the bottom two out to other people. And there's all mix of these different things out there. But it's interesting to start to divide things into this. So I spent some time deriving things called DNS houses. And a DNS house is data-driven. So I run a program, and it will go off and do this by itself. It looks at two things. It looks at what's in the DNS, something called the RNAME field of the SOA resource record. The RNAME is supposedly the responsible identity of who's running the DNS, who's created the zone file. Now, it's not guaranteed to be accurate, but it turns out to be pretty accurate in the DNS core. The operators there have taken time to put in a reasonable value there that can tie things together. And also, there's a technical contact field in a registry for the root zone, managed through the INF functions web. You can get through their website or actually online. And I can use those two things together and weave a little web of connections and create buckets of who's cooperating a bunch of TLD, or who's running a bunch of TLDs out there. Now, in doing this, there are very few large houses, large meaning they have over 100 TLDs out there. There's a couple of them out there. And there are many single houses. It's the typical long tail where we have many that only do 1 or 2 TLDs. Now, typically the large houses are the commercial places, the commercial operators that have done TLDs in bulk. The single houses tend to be the CCTLDs that are running their own systems for whatever reason they have, for whatever purpose they have. So I took my DNS houses and I bucketed up all of the route information I have in the DNS core, and I made this plot. And this plot shows on the bottom from 0 to 100% how far someone has rolled out ROA, meaning that if they're on 100% column, every route advertisement has a ROA covering it. Is 0% on the left-hand side, they haven't started doing anything about it. Now, the height of the dot is how many TLDs they run. And you put this out there and you see pretty much nothing. There's not a lot of organizations, not a lot of dots, basically. Everything's down low, a lot of small bit players in the bottom. The big players stay at either 0 or 100%, and there's not a lot in the middle. In fact, over the months that I've been generating this chart, there's a dot right in the middle. I don't know if I can actually use my marker here, but right here, I don't know if you can see that. Oops, you guys maybe can't see that. Right in the middle of this, about 100 TLDs up and 50%, that dot just appeared one time, and I haven't figured out who it is. So I don't think it has much, there's not a lot of statistical things to say about that. So the AS house, a little more complicated. I had to do some more playing with network names. BGP prefixes, imaginative parsing of the network name, that comes from the Team Cymru listing from the RARs, and some other debatable parsing rules. And wound up that I create pools of AS numbers that may be running together. And one thing that's important here is zone can be multiple AS houses. And I do this chart here, which again, doesn't seem to have a lot to it, but actually seems to be a little bit more organized. And I've used some colors here on purpose here. The green dots, which are all on the left side of the screen, are the large commercial operators. That's a subjective application of that term by me. These are the ones that I've known for running TLDs for a very long time, and they all are staying low on the scale of adoption. One has gone a little bit of the ways up there, but not very far. The red dots, you can see 4 of them easily, and there's actually a 5th one that's visible if you look hard down the bottom. Those are the 5 RARs, and they are all at 100%. Now, you noticed earlier I had a pie chart which showed only 2/3 of their routes are covered. The difference there is that's 2/3 of the routes to their servers that they're running for their zones. If you look at just the routes to the AS numbers that they have allocated back to themselves for their own business, they've done all of the ROA coverage already. In some ways, they have some other, they go to other sources for server hosting that haven't covered their routes. Now, the orange dot is a special one-off. It's not really a special one-off. It's a special and unique organization which has no TLDs. They don't run any DNS. They don't run a registry, but they offer services to many, many, many TLDs, and they're significant in their size for that. But also, they're trying to push sometimes the technology further. Now, this next chart is a blow-up of the lowest part of this. Only the small, the 50 TLD players or less. And you see the other red dot that's there is the last RAR that wasn't too visible before. And there's a slight organization from low to high as you go left to right, but nothing much I would really make a conclusion about. So overall judgment, overall statements, ROs are sparse. There's not a lot of data here. Large non-RAR hosters, AS houses, have low deployment, but the large RAR hosters the large hosters that are not RARs, I'm sorry, the large RAR hosters do have high deployment. So the last 2 bullets there kind of show a contrast in who's rolled it out. There's an inherent risk of adding security to an in-operation system. This is just a background slide to why slow adoption may actually be going on here, that we don't try to if you were to put security into a system that's very critical and the security system itself has an issue, there'll be chaos. So we look for mitigations for this. Now, I've had experience with DNSSEC. DNSSEC is also similar because it was a post-operational application of security to an operating system out there that if it broke it would be really bad. Adoption of DNSSEC has taken a very long time. Over the 2 decades since it started being rolled out, it's only pretty much respectable or visible, and depending on how you look at this. And it's actually been a good thing it's been slow, given some of the early hiccups that happened. Currently, though, DNSSEC sees a different adoption pattern within the DNS core itself. In the DNSSEC core, or DNS core, the large operators have fully deployed it. And what remains to be deployed are in the single CCTLD operators, kind of a little bit different from what I see with the ROAs for who knows what reason. So good questions here. Is it ready for deployment? I'm going to duck the question. I don't want to speak on behalf of operators, explain why it hasn't been rolled out. If deployment ought to progress, what needs to be done? Again, I'm going to duck that question because an operator would be the best source for that information. And so in wrap up, the work that I've done here, it's merely checking the temperature of the room. Is 25% acceptable for now? Maybe, maybe not. Are there possible improvements for this to go forward? And is it a business case issue? I've always heard about the DNSSEC business case not being made. I think that it's probably very hard to make that. Now, relying on my experience with DNSSEC from since 1998, rather, slow adoption has advantages. We used to have lots of bumps with DNSSEC, and because the pioneers were the only ones involved in either the signing or the validation, only the pioneers were willing to smooth over what we saw. There are gaps that still exist in DNSSEC. Some still need to be filled as we go forward. And the other part of this too is that the value proposition may change over time. There was a time when DNSSEC was not solving an immediate problem, but that changed when people's attitudes about that happened. So I hope I'm going to end here and hope that there may be some discussion or questions about it. So maybe other people will be interested in looking at the topic down the road. Thanks.
We'll continue next with Q&A. Edward, what are ICANN's next steps with RPKI other than research? When will we see a ROA covering the L-root IP blocks?
Okay, what is there besides research? Isn't that life? Well, part of ICANN's mission is to basically coordinate and communicate what's going on out there. So research and observations are important to us. And at some point it'd be good to have a dashboard for this. We're thinking about what we can do to do some of these studies over a longer period of time. But in terms of anything else, it's kind of beyond me to really give a plan for what we want to do in terms of the RPKI and ROA deployments out there. And in terms of the operational questions, that's actually not in my area of the organization. I'm going to duck that as a non-operator. I can assure you that the operators we have are well aware of the technology, and they're doing their evaluations. They've tested it, and they are just evaluating whether or not they want to when or if to roll this out at some point. So I'll leave that.
Okay, thanks. Another question that came up is you're aware of detailed studies of the implications or RPKI on robustness of the DNS core. Can you comment on that?
Well, there's a general situation here. Whenever you add a security mechanism to an already running system, you're changing things. So you're making it a little bit more brittle at times. And we did it with DNSSEC in everything since then. When we add on security later, we're risking the original system's health. And so you want to go slowly with this. And it's, without being specific with really detailed answers that would take an hour to explain, basically, whenever you add on security to something, you want to make sure the security system itself doesn't cause a failure down the road. You want to protect and not destroy the system it's running on.
Okay. We are unfortunately out of time. Any final thoughts about observations, anything you would like to share with the NANOG community?
No, just quickly, I noticed that Susan Fournier gave a statistic last night or at the end of the session yesterday where she mentioned 25% was the adoption there. So I think that the measurements have some basis in reality. They're spread further than this. But in general, I want to take this as a measure of, it's not that operators are slow to adopt something, but operators may be reluctant to adopt something. We need to figure that out before we decide whether there's business cases, promotion is needed, or whether or not we need to go further with developing the system to make sure that it is truly adding in security and not risking some of the performance we have today.
Okay. Well, Edward, thanks for joining us today.